शंकरं शंकराचार्यं केशवं बादरायणं सूत्रभाष्यकृतो वन्दे भगवन्तो पुनः पुनः। सर्वेभ्यो सुप्रभातम्। अद्य अस्याः राष्ट्रीयकार्यशालायाः अष्टमं दिनं वर्तते। अष्टमे दिने प्रथमे सत्रे तमिळ्नाडुतः समागताः सन्ति अस्माकम् आचार्याः यस् कदिवरन् महोदयाः कदिरमन् महोदयाः। तेषाम् अहम् अस्माकं कार्यशालायाः पक्षतः स्वागतं व्याहरामि। अद्य ते महाभागाः अस्मान् इदानीं ते अस्माकं कृते न्यासस्य विषये उद्बोधयिष्यन्ति। अतः अहं तान् स्वागतं करोमि। अद्य ते आगत्य मञ्चम् अलङ्कृत्य अस्मान् उद्बोधयन्ति। धन्यवादः।
Good morning, sir. I want to I cannot stand and talk.
So good morning.
Good morning, sir.
So how are you?
Fine.
Okay. So actually in the statistics part there is some left out is there. Let me complete it first. Then we can continue. Right? So don't blame me for statistics again. So actually the balance part is we have to talk about the one-tailed and two-tailed test. One-tailed and two-tailed test. So what is one-tailed test? See, if you take the normal probability curve, you may have the doubt why we are insisting normal probability curve again and again. See, normal probability curve ensures the normality of the distribution. Normality of the distribution. See, all our statistical assumptions are based on the normality of distribution. All our statistical test which follows the normality of distribution. So, without NPC it's very difficult to touch the statistics. Without NPC it is very difficult to touch the statistics. So, if you take the NPC, for example, you think of the critical T ratio 1.96. Yesterday I mentioned about at the 0.05 level for the n is equals to infinite sample, that is 120 above is said to be infinite sample, that is 1.92, 1.96, and this is at 0.05 level. You know how to see the T table. So at 0.01 level it is 2.58. Okay, these are the critical values as per the table. See, 0.05 level 1.96 means if your value is coming here 1.96, if the calculated T value is 1.96 and above, 1.96 and above, we should reject the null hypothesis. We should reject the null hypothesis. For example, I am starting my research with the null hypothesis that there is no significant difference between men and women. There is no significant difference between men and women in the levels of intelligence. What are the variables we can add? There is no significant difference between men and women in the levels of intelligence or IQ level. So I started my research. Now, based on one value, I have to either accept the null hypothesis or reject the null hypothesis. Otherwise, it leads to alpha error and beta error. Yesterday we spoke about type 1 and type 2 error. Type 1 and type 2 error. Right. So here I am using this 1.96 as a cutoff point. Okay, below which I am accepting the null hypothesis, above which I am rejecting the null hypothesis. Are you clear? So in one-tailed test, we have only one rejection region. Got it or not? Got it or not? There is only one rejection region. I am not directly introducing one-tailed test. I am talking about the T value which is already known to you. Okay, null hypothesis which is already known to you. So if the calculated T value is equal or greater than the table value, we have to reject the null hypothesis. And we have to say that the alternate hypothesis is correct. In other words, null hypothesis states that there is no difference between the men and women. Now I am going to say that there is a significant difference between men and women. There is a significant difference between men and women. So in one-tailed test, there is only one rejection region. Okay, hereafter we are not accepting the null hypothesis. Up to this null hypothesis is correct, accepted. Afterwards, we we are not accepting the null hypothesis. This is the idea behind one-tailed test. Are you getting me? Let me repeat. Repeat. See, we want some statistical decision. Either we have to accept the null hypothesis or reject the null hypothesis. Correct. So the table value is 1.96 at 0.05 level. So we calculate the mean value, the standard deviation, and we perform the t operation. T operation. I got the t value as 1.99. 1.99. This value is more than the table value. The table value, this is the table value. This is the table value. This is 1.96. So if it is more than 1.96, simple logic, I'll write here. Mean of the men is 53. Mean of the woman is 57. Both are equal or not? Not equal. They are not equal. But we know that these numbers are not equal, but whether they significantly differ or not, we don't know. For which only we are calculating t value. Okay? To test the statistical significance, we are calculating the t value. Now the calculated t value is 1.99. 1.99. So 1.99 is more than 1.96 or less than 1.96? More than 1.96. More than 1.96. So this is the reference value or table value. This table value is the reference value. This table value is the reference value. So if the calculated value is more than the table value, we have to reject the null hypothesis. We have to reject the null hypothesis. So I have rejected the null hypothesis. I have rejected the null hypothesis. So you know that both are not equal. 53 and 57 is not equal. 53 and 57 is not equal. But whether the difference is significant or not. Whether the difference is significant or not. Which is derived from the t value. Which is derived from the t value. It is like the ready reckoner. I am having this value. See, what about your pass mark? In the UG it is 40, PG it is 50. So 1.96 is like 40. 2.58 is like 50. Now you will not forget. At the UG level the pass mark is 40. At the PG level the pass mark is 50. I am not testing the hypothesis for PG level, I am doing it for the UG level. I am doing it for the UG level. Clear? So the cutoff is 1.96. If the calculated value is more than 1.96, we are rejecting the null hypothesis. Now look at the figure. Up to this, there is no significant difference. Up to 1.96, there is no significant difference. Above 1.96, there is a significant difference we are going to say. That's what called as one rejection region. One rejection region. So in one-tailed test, we have one rejection region. Most of the statistical tools we are using is coming under one-tailed test. We are not using the two-tailed test everywhere. We are not using the two-tailed test everywhere. Then what is two-tailed test? What is two-tailed test? Simple. Two-tailed. Tail means it's like a ball. Tamil la ball nu sollumla. So oru vaale தாங்க முடியாது. Okay? ரெண்டு வால் அங்க. எல்லாருக்கும் ஒரு வால் இருக்குறதே தாங்க முடியல. Okay, so one tail, we cannot tolerate the one tail with like the monkey. If the monkey is with the two tails, just imagine the situation. Likewise, we have two rejection region. So, this is another rejection region. In the two-tail test, we have two rejection region. How it is two rejection region? Where we will be applying it. Where will be applying. For example, in medical research, they use the two-tail test. See, for instance, we can tolerate up to some medicine. For example, I am saying it is 0.50 milligram. Okay? Up to 0.50 milligram, it won't be effective for you. That is why we are giving, for the adult, we are giving more than 0.5. The best example is your Kalpal or Dolo 650. Okay, we are using it as the sweet mithai. Okay, we are eating so much of Dolo 650, and remember all the paracetamol tablets will have its own consequences on your liver. The liver will be liver thrombosis is very much possible if you are regularly consuming Kalpal. And you know very well that all the Indians are doctors and engineers. No doubt about it. No. All are doctors. Okay? See, I'm not joking. If you go to the foreign countries, if you talk about the medicine, he will not talk anything about the medicine unless he is a certified medical practitioner. But our people, hey, if you have cancer, go for this treatment. Okay? See, we don't know what type of cancer it is, or whether a particular therapy will be working out or not. We don't know anything. You take chemotherapy. What it is? You take chemotherapy. Even my neighbor took chemotherapy. Okay? So you take chemotherapy. But if you take chemotherapy, you have to tanch your hairs. Okay? Likewise, we are giving all the suggestion. All we are the doctors. All the Indians are doctors and engineers. Especially we are the popular doctors. We will give the medicine for everything. They are giving medicine for everything. That's why in many of the Western countries, if you are an Indian doctor, they are looking at a suspicious eyes. Okay? Whether you will be giving the right medicine or not. Because all the Indians are doctors. So coming back to this point, remember this and you will not forget the two-tailed test. Come back here. See, Kalpal, 500 gram Kalpal. 500 mg Kalpal. Okay, 500 mg is the cutoff point here. 500 mg is the cutoff point here. Below which, below 500 mg for the grown-up adult, more than 18 years of age, it will not work. It will not work. Similarly, there is a condition, you should not take more than 1800 milligram per day. So, this is the next cutoff, 1800 milligram. 1800 milligram. So, above which you should not take the Kalpal. Per day, you should not take the Kalpal. Below 500, it will not work. Above 1800, it is dangerous. It is injurious to your health. So, below which we are rejecting, above which we are rejecting. Below which we are rejecting and above which we are rejecting. So, this is known as two rejection region. That is known as two-tailed test. So, forget about Kalpal and all. In two-tailed test, we have the lower limit as well as upper limit. So, 500 is the lower limit. Are you getting me? 500 is the lower limit. 1800 milligram is the upper limit. Below which it will not be effective for your body. Above which it is dangerous to your body. Above which it is dangerous to your body. So, in the two-tailed test, we have two rejection region. Two rejection region. So, in our social science research, it is good for medical research. Can you say that if you have the intelligence less than 90, okay, you are useless. If you have the intelligence more than 110, you are also useless. Can you say like that? Sometimes more intelligent people are dangerous. Okay, they are eccentric. That is a different story. I am not coming there. But on the name of intelligence, they will torture everyone. On the name of intelligence, they will torture everyone. So that is also dangerous in the practical sense. But theoretically, hypothetically, we cannot say that. Intelligence less than 90 is useless. Even if we assume zero intelligence, zero cannot be possible. Yesterday I told you. But even the person with zero intelligence will be useful to the society. In some way, in some of the manual work you cannot do, he will do. Okay? In some of the area we need people who just obey our order. Who just obey our order. With our intelligence we will not obey the order of the other people. For example, the common sense. Being on time is the common sense. This is not even in an order. It is actually punctuality is respecting our own moral commitment. But even the teachers are not with moral. That is the problem of the current day society. For example, you are expected to be here by 9:30. Okay? It is pathetic that only myself and Chandrasekhar sir is here at 9:30. Okay? One or two students they came at that time. Right? I am not finding fault with you. But if we are doing like this, how we are going to model the values for your own children? Punctuality is not satisfying others. It is respecting your own moral commitment. Without morality, what is the use of the human being? That's why yesterday somebody said human being. I said we are the so-called human being, not being human. Not being human. See, tell me honestly, even if there is an accident, we are just taking a selfie with the dead body, and immediately we are posting the selfie in the Facebook or Instagram and all the other things. That is a huge accident. Immediately you will be getting the likes. Okay, what is the use of that like? The person who has liked in Instagram or Facebook, whether they will be useful in any way? Remember, today the popular fraud is the online fraud. Popular fraud is the online fraud. They will be liking you, but later you will face a lot of problem with those people. Okay, what's the use of posting everything in the social network? So, even in my punctuality is respecting our own moral commitment. Otherwise, how we are going to mold the next generation? Most of you are going to be teachers. Some of you are already teachers. Am I right? But even if you are not punctual, see, in our university, if it is 9:30 means I will start the class at 9:30. I will not wait even for a single fellow. If no one is there, I will cancel the class and I will go. I will cancel the class and I will go. But people knows me. Majority of the people will be there. If it is my class, majority of the people will be there. Okay, it's not scolding you people. It is for your thinking, because we claim that we have the sixth sense, common sense. We have the sixth sense, common sense. Think about it. And coming back here, so we have two rejection region. Since we spoke about intelligence, I am forced to say all those things. So in the two tail test, we have two rejection region. Then one more thing left out with the previous day topic is t-test. T-test, test of significance, students T distribution. In 1908, William Gossett, he has published the t-test on the name of the students. On those days, today we are writing the article with our name, right? But on those days, there are so many conditions to publish the research article. So just to maintain the anonymity, William Gossett in 1908, he has published the students T distribution. Students T distribution, just now I given an example. 53 and 57 is not equal, we know that. 53 and 57 is not equal. See, 53 is the mean, let me take the bigger value for men and women. Why you have to underestimate yourself? At least the number may be good. So 123 and intelligent genius. 123 and 129. This is the mean intelligence score of men. This is the mean IQ score of men. This is the mean IQ score of women. Okay. So we know that both the numbers are not equal. And statistically we want to know whether men and women differ significantly in their intelligence. So we should go for the students T distribution. There are three type of T distribution. One is one sample T test. Don't get confused, just I am giving the information. One sample T test, which means I am not talking about the men and women. Here I have the reference value. Forget about this example. This is for the second category. Forget about this example. So I want to check whether this group differ from the average intelligence or not. Whether this group, the entire group, differ from the average intelligence. Average intelligence level is 90 to 110. You know the Terman and Merrill's classification. So let us take the average for 90 to 110. Let us keep it as 100. The average IQ of people is 100. I want to check whether the whole group differ from the average or not. So now the whole group is stated as a single group or one group. Single group or one group, for which I am going for one group T test. So the formula is T is equals to x bar minus mu divided by S divided by square root of n. Take out the formula and let me give the meaning for the symbols. You can write it down. So mu is the population mean or hypothetical mean. What is the hypothetical mean? Here now 100. Just now I mentioned it is 100. Hypothetical value is, since it is the average IQ, it is 100. We kept the average as 100. So I want to check whether you are deviating from the 100 or going with the 100. So the population mean, mu is the population mean. In this case, what is the population mean? 100. The reference value. Reference value. Then x bar is the sample mean. X bar is the sample mean. For example, I have conducted the IQ test and I have calculated each and every one of your IQ, and the average x bar is, for example, x bar is 116. 116. And straight away I am telling you, 100 is not equal to 116. That we know very well. That we know very well. But whether this difference is statistically significant or not. This difference is statistically significant or not. So we are going for one group t-test or one sample t-test. This is called as one group t-test or one sample t-test. See, whether you like it or not, as I am repeatedly telling you, if you want to clear the net examination, you must have the basic knowledge in the ecology and stat. Only then you can easily get through the net examination. Then, if you have the strong subject knowledge, that's an advantage. You will get the JRF also. JRF too. Right, it's up to you. So, coming back here, we know that 100 is not equal to 160. But we don't know whether it is statistically significant or not. So, I am going to calculate the t value. Then, so mu is the population mean or the reference value. Reference value, which is the proposed mean. Proposed mean. Then, x bar is the actual mean of this group. Actual mean of this group. Then, S is the standard deviation. While measuring the mean value, we can calculate the standard deviation also. For example, the standard deviation, the calculated standard deviation is 9.6. For example, then n is the total number of cases in the group. Total number of cases. N is the total number of cases. For instance, what is the size of the group, sir? What is the size of this group? 60. Okay, the total size of the group is 60. Whether there are 60 people or not, that's a different question. But we can assume that 60 people are here. 60. 60. Then, how to calculate this mean? So the t value is equal to, this is in modulus. X bar minus mu is always in modulus, otherwise you will get the minus value. It depends. If this mean is lesser, you will get the plus value. If this mean is lesser, you will get the minus value. So we have calculated value is 116. The reference value is 100 divided by 9.6 into square root of 60. So this is 116 minus 100, it is 16 divided by 9.6 square root of 60. Come on, somebody has this calculator. 60 square root.
7.74.
7.74. Now tell me 16 divided by 9.6 divided by 7.74. 9.6 divided by 7.74. 1.24. I was wondering. 114 means I was wondering. 1.24. Now tell me 16 divided by 1.24. 16 divided by 1.24.
12.90.
12.90. So the calculated t value is 12.90. So let me repeat again. Let me repeat. See, one sample t-test or one group t-test is used to test whether the group is differing from the common value or the reference value. Reference value. The IQ range is, normally the IQ range is 90 to 100. But if you use 90 to 100, it will be confusing. So for 90 and 100, 90 to 110, I have taken the mean mid value as IQ as 100. This is the average IQ. Then I have conducted the IQ test for this group and I have collected the IQ data of this group. There are 60 members in this group. Then the IQ mean value is 116. 116. Then if you take the standard deviation, I am working out the mean, median, mode, straight away we will work out the standard deviation also. Then the standard deviation value is 9.6. S is the standard deviation. 9.6. Are you clear up to this point? Are you clear up to this point? Right. So I have calculated the mean value. Now the reference mean value is 100. That is the mu, population mean. The reference value is nothing but the population mean. It is 100, and we check whether you are differing from the population mean or not. So I have calculated the t value, which is equals to 12.90. 12.90. For the, actually you should know one more concept. Yesterday somebody asked, I told them DF. Okay, degrees of freedom. Normally DF is given by the formula n minus 2. N is the total number of cases and minus 2. Degrees of freedom is the possible, permissible or possible permutation operation. Permutation operation. The possible permutation operation in your case is 60 minus 2 is 58. 60 minus 2 is 58. Then you know how to see the T table. Am I right? T table, they have given the 0.50 level, 0.10 level, blah blah blah. They have given the different levels. For the human variable, normally we prefer the 0.05 level, 95% amount of confidence. So in the table, you have to see for the 58 degrees of freedom. For the 58 degrees of freedom, then different levels are there. For the 0.05 level, what is the value? What is the value? This value may be, definitely it won't be more than 4. For the 58, it may be around 3 point something. For example, roughly I am taking 3.5. This is the table value. Is the table value. We know that 100 is not equal to 160. But whether this group is significantly different from the population mean. Significantly different from the population mean. So the table value is 3.5. The calculated value is 12.90. 12.90. So we have to reject the null hypothesis or accept it. Null hypothesis states that there is no difference. There is no difference. We have to accept the null hypothesis or reject the null hypothesis. Reject the null hypothesis. If the null hypothesis is rejected, the group differs significantly. You have the statistical significance. The group differs significantly from the population mean. Are you clear? Yeah, this is the purpose of the one sample t-test. One sample t-test. Forget about the intelligence. Let me give some other example. See, actually it is expected that there should be some human productivity. Human productivity. The company wants to give the increment for the workers if they are working more than the average. More than the average productivity. Per day, it is like a piece system, whatever it may be. It depends on the nature of company. Per day, on an average, everybody should produce minimum 25 pieces. 25 pieces. So now the population mean is 25. Okay? Then I am calculating how each and everyone is performing. How each and everyone is performing. And I can calculate your performance as the standard deviation. I know the number of cases. Then I can perform the t-test, and I can decide whether the group is performing above the general people or below the general people, general population. Are you getting me? So this is the purpose of the one sample t-test. Are you clear? Let me go to this two sample t-test. Right. Whenever we got to compare two groups, okay, in most of our research we used to compare two groups. In most of our research we used to compare two groups. Whenever we want to compare the two groups, we will go for two sample t-test. Two sample t-test is the frequently used t-test. Let me continue with the same example so that you will not be getting confused. You will not be getting confused. See, the mean value I am writing in this manner. M1 is the, because we have two groups. M suffix 1 indicates the first group. M suffix 2 indicates the second group. Are you clear? This is for write in this way so that I need not repeat man and woman everywhere. So this is for men, this is for women. I have the mean value. I am indicating this one as M1. For men M1, for women it is M2. Right? M1 is already we have. No, wait. So for instance, I have calculated the mean. From that calculation, again I am dividing the group into two groups. I am calculating the mean for women separately, mean for men separately. So mean for men is 103. 103. Mean for women is 160. 116. 116. Then standard deviation. Standard deviation. Normally this can be mentioned as ST1. ST1 means for the first group, ST2 for the second group. This is for your understanding. Suffix 1 indicates the first group, suffix 2 indicates the second group. So the standard deviation for men is 10.8. Then for women it is 11.9. For example, I am giving the data. Then number of cases n. This is a common representation. M, S, D, N is just the common representation. Since we have two groups, I am using suffix 1, suffix 1, suffix 1, suffix 1, suffix 2 like this. Then number of cases out of 60, majority is men. So 37 is men. This is called as N1. Then women 37, so 33, N2. Are you clear with this data? It's a just imaginary data. I have generated the data. I have generated the data. Are you clear with this data?
Yes, sir.
Shall we run the other side? Yes, this is for one sample test. May have the question, why should we have the one sample test and two sample test? That's why I have given the second example. In certain area, we need to compare the performance of the group of people from the average, from the population. From the population, there we need one sample test. Then, the two sample t-test formula is T is equals to M1 minus M2, mean 1 minus mean 2 modulus. And one more thing, what I am writing is the simplest way of writing the formula. I can confuse you with a different symbol. Let me tell you. See, mean. Okay, x bar is known as mean. Already I told you yesterday. So x1 bar minus x2 bar. You will be immediately confused. Okay, in some of the sum x divided by n. You can substitute any time. Sum x divided by sum x1 divided by n1. This is also known as mean. This is also known as mean. So I don't want to confuse you with the formulae, various formulae. What I am writing is the simplest way of writing the formula. Are you getting me? So mean 1 minus mean 2. So we are looking at numerical difference between the first and second group. Then SD1 square by N1 plus SD2 square by N2 within the square root. Is it very difficult to follow? N1 is the number of cases in the first group. SD1 is the standard deviation of the first group. M1 is the mean of the first group. M2 is the mean of the second group. SD2 is the standard deviation of the second group. Yeah. Then N2 is the number of cases in the second group. Is it very difficult to follow?
No.
Okay. So straight away we can substitute the values. So M1 is 103 minus 116. This is it in the modulus divided by SD1 square. What is 10.8 the square divided by N1 is 37 plus 11.9 the square divided by 33. Denominator is within the square root. So this is 1013 divided by 10.8 square. Come on, somebody tell me. 10.8 into 10.8. 116.64 divided by 37 plus 11.9 into square 11.9. 14.6. 141.61. Okay. Divided by 33. Just for your understanding, I am writing all the steps. Then again 13 divided by, tell me 116.64 divided by 37. I will do everything with the calculator and will write the final value. But for your understanding, for the first time you may be working out. 3.15 plus 141.61 divided by 33. If something wrong, it's because of you. I am not working it out.
4.29.
4.29. Now tell me, T is equals to 13 divided by within the square root 3.15 plus 4.29.
7.44.
7.44. Again, 13 divided by square root of 7.44. Square root of 7.44. Take the square root. Two point 2.72. Then 13 divided by 2.72. 1 point 4.77. Good. The calculated t value is 4.77. The calculated t value is 4.77. Are you clear? Yes or no?
Yes, sir.
See, only you have given me the value from your calculators. Hope you individuals differ, calculators may not differ. Are you clear up to this point? Come on, yeah.
Yes.
Otherwise, I'll repeat. It's a simple mathematical substitution. You know, we are talking about the education. Any of you have done your BA education? So, education is a man-making process in which we prepare the individual for the fullest adult participation in the society. So, education, the function of the education is preparing the individuals for societal participation. So, you must be thorough with your 3 R's: reading, writing, and arithmetic. Today, we can take the 4th R as the technology. 4th R as the internet, not even technology, internet. So 3 R's of education. So reading, writing, arithmetic. So if you are a literate means, forget about the education and the man-making process, etc. We are talking about the literate, illiterate. Literate means you should be in a position to read something in your own mother tongue. You should be in a position to write something in your mother tongue. You should perform certain mathematical operations such as addition, subtraction, division, etc. with your own mother tongue. Okay? Only then you will be called as literate. You are illiterate or literate? Illiterate or literate? Are you sure you are literate? Then statistics is nothing but performing the same mathematical operations such as addition, subtraction, division, multiplication, finding the square root, finding the proportion with your own mother tongue. With your own mother tongue. Whether you are literate or illiterate? Literate. So you should not say that it is difficult. See, the simple thing is you have to follow what I have done. What I have done. Everything is very simple only. Normally, if you are going for the thesis work nowadays, software packages are available. Somebody will be performing, somebody will be writing interpretation like the ghost writing, and somebody will be submitting the thesis. Okay, I am not coming for that area. But for you, in the examination, in statistics, they ask the question. Okay, you must know how to substitute the values, otherwise you cannot write the exam. Otherwise you cannot write the exams. Or even for the net exam or something else, or any competitive examination, only you have to write the exam, not the ghost writing. Thesis you can go for ghost writing, but examination you have to go. Or you are changing the people there also in Andhra Pradesh? No, okay. So coming back here. So the calculated t value is 4.77. Are you clear up to this number? What is the reference value already we have for the 60 df? Say for the 60 means n minus 2 is the df. N minus 2 is the df. So 58. For the 58, what is the value I have written already? 3.50 or something. What I have written? The previous example. Let us keep the same example. What is the df value I have written? Table value I have mentioned something.
3 point something, sir.
3.5. Okay. So the table value is 3.5. This is the reference value or table value. Table value or reference value. Now the calculated value is 4.77. Okay. Then now we are rejecting the null hypothesis. Our initial null hypothesis, men and women do not differ in the intelligence level. But now we rejected the null hypothesis. So what we are going to say? Men and women differ in the levels of intelligence. Okay, now they differ. Now we can, from the mean value, we can say who is possessing higher level of intelligence. Now we got the statistically significant difference. So which mean is higher? So compared to men, women possess the higher level of intelligence. That is the conclusion. That's the conclusion. Am I clear? Yes? Yes. This is with regard to 2 sample or 2 group t-test. 2 group t-test. If there are 3 groups, we can go for ANOVA. We need not calculate The problem with the 3 group and more than 3 group is, if there are 3 groups, for instance, group 1, group 2, group 3, we have to calculate the T between G1 and G2, group 1, group 2, G2 and G3, then G3 and G1. So thrice you have to work, rather straight away you can go for analysis of variance. That's a multivariate analysis. Analysis of variance. You need not compare each group. Are you clear?
So, sir, here,
Yeah, please.
there is
Please. Any question you can ask. I am happy that at least you are asking questions.
by the mean value itself, you are coming to know that women are high in the.
Yes.
Why this 4.77 is needed?
Yeah. The problem is you came late, am I right?
Yes.
Yeah, that's the problem. Okay. I told very clearly. We know it's not equal. It's not equal. But whether they are statistically differ or not. Okay. Now they statistically differ. From the t value, we proved that they statistically differ, which means there is a significant increment. The 103, 160, there is a significant difference. That is why we boldly claim that women have higher levels of intelligence. To decide about that.
4.77 is for the women.
Which one?
4.77.
No. 4.7.
Calculated t value. From the t value, we have rejected the null hypothesis. Our assumption is men and women do not differ significantly in their levels of intelligence. There is a numerical difference, but we don't know whether it is statistically significant, for which only we have performed the T operation. Now, we proved that they differ statistically. Now I can boldly claim that women have higher intelligence. This is my conclusion. Women in this group have higher intelligence. So to conclude that, we have to perform the statistical operation. We know that 1 and 2 is not equal. 1 and 2 is not equal. 1 and 3 is not equal. But whether they differ statistically, it depends on the standard deviation value, number of cases value. If the sample size is higher, the standard deviation will be easily nullified. The standard deviation will be lesser. If the sample size is lesser, the standard deviation will be very high. Okay. See, I know that already people taught the measures of central tendency, etc., etc. That's why I am not touching upon it. Straight away I am going for the calculation. For example, your doubt will be clarified. Just a minute. Sir, if you want to take the photograph, take the photograph. I won't drop the board. Yes, ma'am.
Sir, can we say this in this manner, that to establish the accuracy of the significant...
There is no accuracy. Statistics use a lot of approximations. I am not using the word accuracy, perfection, etc.
Sir, since we know that both the means are not same, we want to significantly establish the difference.
Not significantly established. Whether the difference is significant.
Significant or no. But can it not mean that, is it accurately to define the accuracy between the significant...
It's not accuracy. Accuracy is something different. This is not accuracy.
Statistically, we are saying means what we are saying that statistically.
Just a minute, I am coming. I am coming. Take the photograph. Those who want to take the photograph, take the photograph. Yeah? I want to show how the standard deviation differs. Only then you can easily understand. I don't want to go back, but since you have the doubt still, I have to clarify. See, actually, we take the normal probability curve. This is the mean median mode. The curve is perfectly normal. This is mean median mode. This is mean median mode. Standard deviation is standard deviation indicated by the symbol sigma. Sigma. This is the positive side of the curve. This is the negative side of the curve. So, for example, this is 1 sigma. You need not write plus. For the plus, even without plus, that is plus only. Okay, 1 sigma. This side, see how we are habituated to write plus 1. Okay, this side it is minus 1 sigma. Minus 1 sigma. So, if this is the standard deviation, the mean value is like 50. From here to here, the difference is 50 into 1 sigma. 50 into 1 sigma. This side 50 into 1 sigma minus. So, which means this side is, for example, the standard deviation value is 3 for instant time side, for roughly side. So this side it is 50 into 1 sigma means 50 into 3, this is 150. 150. This side it is minus 150. Minus 150. So we know that you differ, but whether it is significant or not, we don't know. Significant or not, we don't know. That is why we are calculating standard deviation. Standard deviation is the standard error of the deviation. Standard error of the deviation. So when you calculate the standard error from the proposed value, this is like the in the previous case it's like the population mean. This is the reference value. This is the mean median mode. This is the normality. If the curve is properly normal or perfectly normal, the mean median mode will be more or less the same. From here, how we are deviating? How we are deviating? That is the standard error. Standard error. So we know that both the numbers are not equal. Both the numbers are not equal. See, in the standard deviation formula itself, we are calculating the standard error. Directly I have given the number, so you need to understand. In the standard deviation formula itself, we have the standard error. So we measure the standard error from where we are calculating the t value. SGY square is the standard error of the squared value of the standard error of the distribution. Clear? So we are taking all the possible error into account and we have calculated the t value. We calculated the t value. That is why Vaishnavi we are testing only whether it is a significant, statistically significant or not accuracy. Not accuracy. This is the answer for your question. Now you got the answer. Clear? So we take the error into account. What is the maximum possible error into account, and we are computing the same inside the formula. We are computing the same inside the formula. That's why it's the better value. Not accurate value, better value. So with the better value, we have certain rules, standard rules. Based on the rules, we check for the particular DF what is the table value. With the table value is the reference value. From the reference value, whether your calculated value is higher or lesser or equal. The thumb rule is if the calculated t value is equal or more than the table value, the null hypothesis has to be rejected and vice versa. Hence, I have rejected the null hypothesis and I have concluded that there exists a significant difference. Now, I have proved that there exists a significant difference. That is why I am claiming that women have higher intelligence. Now you got the answer. First, I have proved it is the statistically significant difference. Otherwise, I should not claim that. Hope I am clear. The third one is I am dead against of confusing people with formulae. I know many formulae, that is different, but I don't confuse the people with formulae because many of us have the aversion about the mathematical formulae. Right. So coming back, the third t-test is paired sample t-test. Paired sample t-test. Okay, paired sample. I will give the formula, don't worry. I will not work out the problem. Paired sample t-test. So there are three kinds of t-tests. The first one is one group or one sample t-test, two group or two sample t-test. This is paired sample t-test. For example, you are taking the experimental group and you are providing the treatment. For instance, I want to give the Sanskrit training, Sanskrit pronunciation training, because you are always fond of Sanskrit in this university. So I want to give many people are good in writing the Sanskrit, speaking the Sanskrit, but what about the pronunciation? There is a difference. There is a difference. So I want to give the Sanskrit pronunciation training. Pronunciation training. So in this case, before you are attending my training, I am taking one mean value or one score for which I am calculating mean, standard deviation, etc. After 21 days of training, normally remember many people take the experimental intervention. Whenever you are taking the experimental intervention, ensure that you are providing minimum 21 days of training for anything. The simple attitudinal change requires minimum 21 days of training. 21 days of training. Actually, let me come with the story so that you will not forget the magic numbers. Actually, one fellow has died. Okay, so he brought before the Yamadharma and he was committed equal number of good, equal number of sin. So 50-50 is always dangerous. Even Yamadharma got confused. Yamadharma got confused. So he said, see, you can decide because you have done 50% of the good deed and good 50% of the sin. You can decide whether you want to go to hell or heaven. It's like our Indian fellow. So, sir, can I have a glance and look at the hell as well as in heaven? Hell as well as in heaven. Okay. So everybody is looking for the heaven. So first he want to visit heaven. So he went to heaven. The first door was open. It was written silent. Silent. People are reading. Hey, Babre, already we have been tortured in the Sanskrit university that you have to read. Even here we have to read. Okay? Then he has opened the second door. He has opened the second door. People are working. People are working. Already we hate how to work. Okay? People are working. So we have to read, we have to work. Whether is it heaven or something else. Then the third door, he has opened the third door. Then people are meditating. So in the heaven we have to read, we have to work, we have to. Okay, why the hell these people said that it is heaven? Okay, then you want to go to the, you want to have a glance at the hell. Then when the first door was opened, girls are showering the flowers. He was very happy. Yeah, this is the welcome. Okay, when the second door was opened, girls are dancing and taking him. They are hugging and he is also dancing and moving with the girls. This is real heaven. When the third door was opened, they have provided the Somabana, Surabana, everything, and he was enjoying like anything in the third door. Okay, he straight away went to Yamadharma and said that I will go to the hell. I will go to the hell. Because who will read, who will work, who will do meditation? Okay, so I will go to heaven. So up to the first third doors, the same thing happened. When the fourth door was opened, Yamagekra started beating him with the nail. Then in the fifth door, they put him in they boiled him in the oil and he was crying. When the sixth door was opened, he was fired. Okay? So he was running and went to the Yamadharma. Whenever we have the problem, we will put the blame on the other. Yamadharma, is it correct in your regime? Yamadharma got doubt whether I made any mistake. What happened? See, he has explained whatever happens in the hell, whatever happens in the heaven. Hey, the first three doors are our marketing department, man. The first three doors are our marketing department. Okay, so we know very well. If we have the proper marketing, we can drink poison also. I think in Andhra, I have seen many people are fond of drinking Pepsi, Coke after the food. Okay, so you became the born American nowadays. Only in America it is mandatory. Okay, Andhra people are becoming Americans. Right? You know the pesticide value in the Coke is 13.8%. Okay, which is the root cause for your cancer. Which is the root cause for your cancer. But when the Salman Khan or Shah Rukh Khan is jumping, Dil Mare Dam, okay, you will be very happy. Shah Rukh Khan himself is drinking Pepsi. He never drink a drop of Pepsi. He never drink a drop of Pepsi because he know the consequences. He know the consequences. Only we are drinking and seeing the advertisement. So seeing is believing. Seeing is believing. The reason is whenever we see, without filtering, the information will be entered into a subconscious mind. There is no filter. There is no filter. The information will be running into the subconscious mind directly. That is why children in the initial stage, they don't have the filters, critical filters. So all the information will be directly entering. You can see many of the children watching the video games. They behave like the character in the video games. The character in the video games or in the cartoons. Okay, Beam Boy. Okay, if you are Chota Beam or Beam Boy, if the boy is plumpy like this and he is taking something, how does it look like? But we like that. We like that. But imagine if you are really like that. Could you see the person? Immediately you will be taking him for the treatment for obesity. Treatment for obesity. So, the visuals without filtering enter into the subconscious mind. Without filtering enter into the subconscious mind. That's why we should be extra cautious about dealing with our own children. But all we have the hurry sickness. All the people are on hurry, but no one is on time. That is our speciality. Always we are in the hurry, but nobody is on the time. Nobody is on the time. So we have the hurry sickness. On the name of hurry sickness, we forget to take care of our own children. We forget to take care of our own children. See, up to the age of 12, what the child requires is the love and affection from you, not the video game or the material comfort you are providing. But initially what we are doing, we are making the child to be comfortable with all the materials. In the later stage, if the child asks something, we are blaming the child. Okay, you are demanding too much. Yeah, demanding too much. Coming back to the Helen ad. Right? See, the first 3 doors are our marketing department. So 3 is the magic number. You may raise the question, sir, why after seeing the first door, after seeing the second door, you made the decision? That is how the brain is made up of. That is the reason, whenever you are chanting the mantra or doing something, you are using the 3 times, 7 times, 21 times, 48 times, even one mandala is 48 days, mandal puja. So one mandala is 48 days or 108 topkarnam. You are doing the topkarnam for the Pilayar 108 times. All these things are based on the magic number. Brain is the logical organ. Brain is the logical organ. Only when you cheat the brain, it will believe. Only when you cheat the brain, it will release the stress. It will release the stress. So, if you take the training programs, 3 is the magic number, 7 is the magic number, the multiplication of 3 into 7 is 21, which is also a magic number. If you have a doubt, go through the mathematics textbook and check what are all the magic numbers. Somebody from MSc Mathematics would be here. So, check your mathematics textbook. What is the magic number? So, any training program should be given for a minimum of 21 days. Minimum of 21 days. Just because you are providing training for 2 days, you cannot claim that you are effective in your training. You are effective in your training. So, any training program, because I know that you will be taking up some of the experimental study for your research. That's why I am insisting upon the 21 days. So, minimum 21 days. Even if it is for 1 hour, for example, meditation, 1 hour, minimum 21 days it should be provided. Only afterwards you should check the effectiveness of your meditation training. After 21 days of your meditation training. Then, I am giving a meditation training, for instance. So, before meditation training, I am measuring your level of performance or whatsoever it may be. Whatever the variable I am considering. Then after 21 days, I am measuring the, yes? Yes, you raise the hand, I got it. After 21 days, we measure what are the variables of our study. Then before 21 days, after 21 days, we have 2 different values, which is the 2-group test. Which is the 2-group test. Then paired sample test. I mentioned that the third one is the paired sample test. Where comes the paired sample test? See, actually, I am a teacher, I am offering the meditation training for one group of people. One group of people. Then another teacher, he is offering another training for the same group. So there are 2 different training. There are 2 different training. Training 1, training 2. Training 1 and training 2. The similar training, only then we can apply the paired group t-test. So I have offered my method. For example, Isha Yoga. I am offering the meditation. The other teacher is offering the same yoga, Isha Yoga, in his own way. In his own way. So trainer 1, trainer 2. So training 1, training 2. But the sample group is the same. So when we have the same sample with 2 different treatment, the training is called as treatment. Don't think of medical treatment. Okay? The training is called as a treatment. So we have the same group, same sample group, and 2 different training programs are offered to the same group. Now I want to see the effectiveness. In this case, I am using the paired sample t-test. Are you clear? One sample t-test, we want to check whether the single group is differing from the hypothetical value or the standard value. 2-group t-test, we are comparing 2 different groups, which is the popularly used test. Right? Normally in the achievement test, we can use the paired sample test. Okay? See, remedial coaching, remedial classes and all, achievement test will be conducted. So I want to check the achievement of the group before treatment, then after treatment, then after 1 month of the treatment. How it is lapsing for a long period of time. How it is lapsing for a? That is called as retention test in achievement test. Retention test. Pre-test, post-test, retention test. So I want to compare post-test and retention test. In which case I am going for the paired sample t-test. So I am giving all the possible situations. So the formula for the paired sample t test is T is equal to summation D divided by N into summation D square minus summation D the whole square divided by N minus 1. This is within the square root. This is within the square root. D is nothing but the differences in the rank, differences in the first and second group. Okay, and just I am going a little bit advanced. Though it's not necessary, you should know how to calculate this D. It's very simple. Let me take the same group example, 60. N is 60. There is no doubt at all. Okay, with the first training, your score is 30, 54, 24, etc. etc. This is the first training, training 1. Training 2 score, 31, 53, 58, etc. etc. Now I am calculating the difference, D. This is like your rank order correlation. I am seeing the formula, you can get some idea. It's like your rank order correlation. Not exactly the same, but the idea is the same. So what is D? So 30 minus 31 is 1 difference. 54 minus 53, 1. 24 minus 58, the difference. I am calculating only the difference. So 34. Likewise, I am calculating the differences. Likewise, I am calculating the differences. Then D square. All the other things are same. Some D square. You can substitute and get the value. I think mostly you will not go for this. But when you talk about the t test, you should know about this also. That's the idea. Are you clear? Shall I go further? So I stopped about all the statistics with this. So sampling, next topic is sampling. Sampling, you can project it. Surface sampling. If you wish, I will give my written notes also. I will give my written notes. I have a lot of notes.
Thank you, sir. Please.
I used to write a lot of notes. Look at this. Now I am converting all these things into soft copy. The papers are getting broken nowadays. Yeah, sampling. It's a sampling. It has to be switched on. Which button? This one. Yeah, come on, hand, right to hand. Right to available. Yes, I don't want to text. Wrong question. It will take a long time again to get it started. Okay, on. Off on. But the light is
Light.
Yeah, now it's switching on. Correct. Yeah, light is coming. Now it's coming. Yeah.
Lights off.
Lights on. Hello. Hi. Yeah. Are you here? Yeah. Yesterday already I have started your population sample and how to draw the sample, etc. Do you remember that? Do you remember that? Yes or no? Yes. Yeah, already we have done it. Yes. Then, what is population, sir? I mean, move it. What is population? No, little bit down. No, sir. No. Go to the top. Page number 1, top. No, page number 1. Yeah, next point. Before which? Before point. Yeah. When is data collection from your population preferred? Okay? When we prefer the data collection from the population, if it is a census. But data collection with the population involves a lot of TMP factor. That's what discussed. Time, money, personal factor. Time, money, personal factors. And even yesterday I have described what are all the things we are manipulating with the population. When we do the census, what are all the things we are manipulating. So these are all the when is data collection from your population preferred. Okay, number 1, small or accessible population. For example, I want to do my research only in the National Sanskrit University, Tirupati. There are about 1,200 students at the maximum. Am I right? So I can meet each and everyone inside their class. Even today you might be absent, but tomorrow you will be coming. So I will meet and collect the data. You must give the data and I can collect the data. I can collect the data. So when the small or accessible population is available, we can go for complete population data collection. Number 2, census or complete enumeration. We want the biometric Aadhaar. Biometric Aadhaar. Then we are connecting the Aadhaar with this one, the PAN with that one, and we are doing all the connection. Because if you are not doing so, your income will be cut. Your bank account will be withheld. So you are doing it. You are doing it. But in research, we cannot compel. Okay? That is a condition, coercion to participate in the research. I am not willing to participate in your research. I have that right. I have that right. So, if it is census or complete enumeration, we can go for the complete population. Number 3. So next. So come on. Unique or critical characteristics. Unique or critical characteristics. For example, the Sanskrit University case. Here, you have the unique or critical characteristics that everybody is speaking only in Sanskrit. Everybody is only speaking in Sanskrit. So it is easy for me to locate you people within this Sanskrit University and I can collect the data. Fourth condition, legal or regulatory requirements like Aadhaar. The best example is Aadhaar. Already I told you. Next. Precision or accuracy requirement. Precision or accuracy requirement. For example, to decide about the social welfare schemes. I have to meet each and everyone and conduct it is the extension of your census. It is nothing but the extension of your census. Right. So in this situation, conducting the research with the population is okay. But is it possible to conduct the research with every population every time? As I mentioned, time, money and personal factors. I want to make a quick inference about certain things. So instead of going for the population, they are going for the sample. They are going for the representative population, that is known as sample. So coming down. Sample, need for sampling. Sampling, it says the TMP factor. Whatever the problem in the population is, it is the plus point here. TMP factor. Then we can make the quick inferences. Then easy for data collection. Then population. For instance, you want to do the research. I want to know the attitude of the people about the government schemes. Attitude of the people about various schemes of the state government or central government in Andhra Pradesh. Which means Andhra Pradesh is a huge state. Even after bifurcation of Telangana, Andhra Pradesh is a huge state. Okay, only 9 districts have been bifurcated with Telangana. So Andhra Pradesh is still the huge state. Within this state, it is very difficult to meet each and everyone and get the opinion. So I choose some packet of people. For example, from the city area, from the town area, from the village area. I am taking some people and I am collecting their opinion. Since you are the representative of the whole population, I am generalizing the result. Like the sample mean as the population mean yesterday in statistics we said. So I am generalizing the opinion of this group as the opinion of the whole population about the government schemes. So this is the need for sampling. So first we should decide about which is the population. The population is also called as technical universe. This is the universe of my study. People in Andhra Pradesh, all the people in Andhra Pradesh is my population or universe of the study. Number 2, sampling frame. From the government data, I can prepare the sampling frame like the age group of the people. Between 10 to 20, how many people are there? From the birth and death register, from 1980s onwards, in all the states, the birth and death register is maintained. People those have crossed 50, you may not have the birth certificate. But people below 40, definitely you have the birth certificate. The register is maintained. The documentation has started during 1980s by the state government and central government. So birth and death register. Death register is always maintained, but birth register. So from the birth certificate, you can calculate the age. Okay. For example, 0 to 10 years, how many people are there? 11 to 20 years, how many people are there? Likewise, I can prepare the list that is known as sampling frame. In the sampling frame is the list of the population in which we are considering all the traits to be studied, all the characteristics to be studied. That is known as sampling frame. The next is sampling design. Which design we are going to use? Whether we are going for probability sampling or non-probability sampling. For example, according to my convenience, I have selected the Hyderabad. Sorry, Hyderabad is not university now. I have selected Ongole. Then I have selected Guntur. These are all the cities. Then Tirupati. Tirupati is a city or town? Town only. Tirupati is still town. Tirupati is town. Okay, town area. Then nearby Chittoor, I have taken some village. Likewise, according to my convenience, I have selected Tirupati. You call it as city, but it is not coming under the city category.
It's a smart city.
You use the word smart city, but it is not city. The meaning for the city is entirely different. Okay, I forget Tirupati. I am not coming for the social debate. Okay. So I have picked up some packet of people. I have collected the opinion and I have stated that this is the opinion of the people. So according to my convenience, according to my comfort, I have selected the sample. I have done the work. Okay. This is called as non-probability sampling. Non-probability sampling. Right. So which sampling design has to be used? Then what are the statistics and parameters you are going to set? This is what I said yesterday. Many people, we don't know the research methodology. The reason is, without knowing the research methodology, we set some values and test some values and we write the t-value in minus. T-value is in minus. Even in regression also, some people will write the t-value with minus sign. Regression coefficient. Actually, the coefficient of regression with the minus sign indicates the negative influence. The coefficient of correlation with the negative sign indicates a negative relationship, inverse relationship. But t value cannot be minus, f value cannot be minus. F value cannot be minus. Right. So you have to decide what is your test statistics, whether you are going for the t distribution or f distribution or multiple ANOVA, whatever it is you have to decide. Then sampling error. Sampling error. So while doing the sampling, we are getting a lot of sampling error. Sampling error. What kind of sampling error? What kind of sampling error? The simple thing, I am not giving properly the data. That itself creates the error. That itself creates the error. Unwilling to participate. Or especially when you are using the psychological test with 5-point responses, 7-point responses and all. Our people are very clever. They know how to give the answer for all the questions. Okay? If there are 5 values, 1, 2, 3, 4, 5, strongly agree, strongly disagree, neutral, whatever it may be. Like that we have the 5 categories. Some people always give the 3, 3, 3, 3, 3. This is called as error of central tendency. Error of central tendency. Some people, they like the zigzag pattern. They like the zigzag pattern. So they will start the response from here. They will do the response like this. Okay? Okay? They are fond of zigzag patterns. Zigzag, zebra crossing. Okay? This is also another kind of error. Okay? Likewise, in sampling we can create so many errors. We have so many errors. And I am unwilling to participate, but as a teacher you are compelling me to give the data. I am not at all interested to participate. Then what I will do is, I will give the answer for this question. Then I will left out these two. And I will give the answer for this question. I will give the answer for this question. What can you do? Finally this data will be discarded. You should not use it. This is called as data screening. Data screening. We have to screen the data. Whether the people have given the answers in the proper manner. How to decide? You can see extreme answers can be ignored. Again I will go back to normal probability, you will be getting bored. But that is the best method. After getting the complete data, for example, I want 500 sample. But for the safer side, I have collected 1000 sample. 1000 sample. Again, I am using the normal probability. Why researchers insisting the normal probability? For the simple reason. So I collected the 1000 sample and I calculated the values. This one is Q1, this one is Q3. Am I right? This one is Q1, this one is Q3. Ignore all the data between these two. Q2 and Q1. Q2 and Q1. So thereby this will have the finer discrimination. This data will have the finer discrimination. This is the best method for data screening. Calculating the quartile values and discard the data between the quartile 1 and quartile 3. The middle values are discarded. But this will involve again a lot of time and effort. You have to collect double the data, only then you can decide like this. Only then you can decide like this, but you will be getting the finer discrimination, all the results will be fine. All the results will be fine. You are allowed to do so. You are allowed to do so.
How, sir?
Huh?
How? Why in between if you...
The middle values are always leading to the problem.
Okay, that's the central tendency.
Yeah, central tendency. So, there are about 1000 data, below which I have 135 data, above which I have 260 data, in between data I have discarded. Now I have taken the data of these 135 people, these 260 people, that itself is the largest sample. That itself is the largest sample.
Will this, by this we can
Avoid the error of central tendency.
No, avoid the sampling error.
Yeah, we can minimize the sampling. We cannot avoid the sample error. This is a human error. So we cannot avoid it. We can minimize it. Sampling error cannot be avoided. It can be minimized.
Yeah, like yesterday I asked online if I conduct a...
Yeah, your problem. Most of the men will give the data in the name of women. Like the fake ID in the social networks. Fake ID in the social networks. I don't prefer the online data collection. Because most of the data is waste. Just for the sake of giving the data, people are giving the data. Nowadays we are getting so many requests in the online. Okay, how do you find time? That too, online data collection is a torturing process, you know. It is based on the Google form. So every answer you have to enter, that has to be disappear, only then you can go to the next answer. Okay, it will be a time consuming process. How do you expect that people will give the correct data? See, in psychology, when we are calling the people as the subject for our experimentation, we used to give them incentives. Not directly the money, rather we can provide them the fruit juice or coffee and biscuits. Like in the break time we are expecting the coffee and biscuit as an incentive, right? Likewise we are giving the incentive. Yeah, giving the incentive. Or in some of the data collection, the big companies, when they do the data collection, they will be recharging you. If you are providing the proper data, 1000 data, you will get the 1000 rupees recharge. 1000 rupees recharge. So, human being needs some motivation. That starts the bribing. Okay? Human beings they require some motivation. So, bribing.
Actually, that leads to more error in data, sir.
No.
Maybe. Because for the money, I will...
Yeah, again, there are so many debates. I am not for the debates. It may lead to the data, but I am using the word incentive, not only the money. Money alone is not the incentive. Even your tea and biscuit is the incentive. Okay? Since you are listening to the people, it's very difficult to listen from the opposite side. You are listening to me for a long period of time. Definitely you feel you are tired. Because since 10:15 only many people came. So you definitely must be tired. So you must have the tea or coffee. You must have the tea or coffee. That's an incentive. So incentive is required at every stage of our life. See, even the children, why you are saying you are a good boy, good girl, that's a kind of incentive. You are greeting the child. You are greeting the child. Rather, we have to say that you have done a good job. But that's the right way of handling the child. But we used to say goodbye. We never developed our morality beyond that level. Goodbye, good girl morality. Right? So we have to say that you have done a good job. What you have done is wrong. You should not say that the person is good or bad. The job which done by the person is good or bad. Okay? So, but we evaluate the person rather than the work, rather than the job done. Clear? Right. So the next point, precision. How precisely we are expecting the sample. Next, confidence level and significance level, then sampling distribution. So coming back, down. I want to finish it. Steps in sampling design, you have to decide the type of universe, sampling. See, everything is explained in the notes, you can read it. Okay? I have given the overall idea, budgetary consideration, sampling procedure. Then next, criterion for selecting characteristics of the good sample design. Next, sampling design, sir. Up. Yeah. There are two type of sampling. There are two type of sampling. There are two type of sampling procedures. One is probability sampling, non-probability sampling. Non-probability sampling. Probability sampling and non-probability sampling. Under probability sampling, we have 7 different methods of sampling. Simple meaning for probability sampling, we are ensuring each and every person in the population to be selected as a sample. We are ensuring that each and everyone in the population may be selected as sample. That is the meaning of the probability. Probability is equals to 1. If it is 1 probability means every person has equal opportunity to be selected as a sample. Right. Another probability sampling, the first one is simple or unrestricted random sampling. Simple or unrestricted random, which means randomness is nothing but ensuring the equality. So simple or unrestricted random means using the lottery method I can select a number of sample whatever I require. Okay, I have the list of 1000 participants in the 1200 students in the Sanskrit University. Then using the lottery method I have selected the sample. But the problem with the lottery method we have the Fisher's table of random numbers. Okay, using that table that will be keep on generating. So second person can be selected as sample, 72% can be selected as sample, 452% can be selected as sample, again 37th person can be selected as sample. So we are assuring the equality. Anybody can be selected. We don't know who is the 7th person, who is the 452%. But the problem here is, when you go for the lottery method or Fisher's table of random numbers, the problem is, we may not get the equal number of men and women. We may not get the equal number of men and women. Majority of the people may be men or majority of the people may be women. That is why we are looking for the finer method that is known as stratified random. Stratified random. So, in the same lottery method, for example, I have decided what are all the strata or conditions. Strata are the conditions or categories. I want to compare the men and women. This is my first condition. This is my first condition. Among the men and women, I want to ensure that 50% of the people from low economic background and 50% from above economic background. The same thing here. Then within this 50%, 25% from the rural background, 25% from the urban background. Rural, urban. So how many stratas I introduced? Both men and women. First strata, then economical status, then locality. Likewise, you can decide the number of strata, whatever you want to study. Then after deciding the strata, under the particular strata, you can use the Fisher's table of random numbers or lottery method. This will be ensuring the equal participation from every category. This is known as stratified random. Within the stratified random, we have further classification. Don't get confused. Proportionate or in-proportionate sampling. Proportionate means, see, if there are 100 people, we need minimum 10 people. In proportionate or disproportionate means, we need not bother about the 10 people. We are using a random number, we have selected some person. But both will give the same result. Then the third sampling is systematic sampling. I have listed out all the 1200 people with each and every strata. I am selecting every kth unit. K, I am deciding K is equal to 3. Third person. Again 3 plus 3 is 6. Sixth person. 6 plus 3? 9. R, multiplications of 3. K is multiplication of the 3. First third person. Then 3 into 3, 9th person. 9 into 3, 27th person. Likewise, I am selecting the sample. This is called as systematic sampling. Then the fourth one is cluster sampling. Fourth one is cluster sampling. Go back to the previous example. I want to study the opinion of the people about the governmental schemes in Andhra Pradesh. Andhra Pradesh. Already I have given the example. I have selected two urban area, two rural area, then two middle class area, semi-urban, suburban or semi-urban. There I have conducted the study. This is called as cluster sampling. Instead of the individual, we take the group or the locality as a cluster. Instead of the individual, we take that particular group, particular village, Ongole city. So I have to collect the data from all the people in the Ongole city. Ongole city, that is called as cluster sampling. Cluster sampling. Then next one is incidental sampling. Incidental sampling. Actually, in some of the cases, you cannot follow any of the sampling design. For instance, with the clinical cases, whoever is coming for the treatment can be treated as taken as a sample. Okay? You cannot assume that 120 people are mad inside this group or inside the Sanskrit university. Okay? That is unethical. That is unethical. So, whoever is having the problem, they are coming for the treatment. Clinical population, whoever is coming for that is an incident. That's an incident. We are not assuring the randomness, but whoever comes will be considered as a sample. Another example for the same thing. See, we are people are saying that this rating of this program is good, this program is very good, etc., etc. TRP rating. In the television and radio, we have the rating. The rating, whoever gives the opinion, I cannot ask you, each and everyone to give the opinion. So whoever the viewer is giving the opinion, I am taking it as the opinion of the viewer. Okay? That is called as incidental sampling. That's known as incidental sampling. Then the next one is double. Hello. Double sampling. Hello. Hello. Yeah. So in our department is in the left hand side, but it was not there already. I see. So think now. Then switch it up. Otherwise it will be echoing. Whatever. That is change. Hello. Yeah. So the next one is double sampling. It's very simple. Using any one of the procedure, first you select the sample. From the sample, again using the same procedure, you can select the further sample. That is called as double sampling. That's known as double sampling. Then the next one is sequential sampling. Sequential sampling only. I have the doubt whether I have typed the mistake. Sequential or sequential sampling. In the sequential sampling, using any one of the procedure, you are selecting the sample, but you are ensuring that every, for example, 100 unit, 200 unit, this is like the systematic sample. But until you are satisfied with the number of sample, you can go for sampling, which is very difficult. The sequential sampling is very difficult. It will increase your sample size. Until I have taken the last fellow. For example, in the inside the Tirupati area, people are bothering about the word city. Inside the Tirupati area, there are about 6,002 population is there. So, from the first sample onwards, up to the 3,60,000 to 2,002 sample, I am selecting all the 100 unit as the sample. This is sequential sampling, but again it's a larger sample and it consumes your time. Then non-probability sampling. We are not assuring any equality. According to my convenience, I am taking the people. I prefer the data collection with the particular group of people, so they are my friends. I have collected the data and I am making the inference. The most important condition is, once when you go for the non-probability sampling, you should not go for parametric statistics. Because you cannot assume about the population. Okay? In other words, in the non-probability sampling, we can say that, see, this result is whole good for this group. That's all. This result holds good for this group. I have done it for this particular group.
Action research comes under.
Yeah, action or research comes under the non-probability sampling only. Right. So, in some of the occasion, we go for the non-probability sampling. It's very simple. If you don't have any assumption about the whole population, you can go for non-probability sampling. It's up to you. But the simple condition is you should use the non-parametric statistics. So there are different types of non-probability sampling. Judgment or purposive. As a teacher, I know which area is better, which area is down. So according to my judgment or purpose, I am selecting the sample. That's known as judgment or purposive sampling. Judgment or purposive sampling. Number 2, quota sampling. With the same judgment, I am using some of the strata, like man, woman, etc., etc. But it is the non-probability sampling. That's known as quota sampling. Number 3, accidental sampling. Accidental sampling. Okay. See, I am choosing the sample according to my convenience. Okay. But those are the only people available for the purpose at that time. That is called as accidental sampling. It's an accident. Okay. I am taking class is not an accident because it was pre-planned. But attending my class for you people is accident. The program is pre-planned. So it is not accident. I am coming here and taking the class is not an accident. Not an accident. But it is your fate of the people. You are attending my class. That is accident. That is accident. My presence is pre-planned by your teachers, by the program coordinators.
It is also
No, it is predestined. This is known as accidental sampling. Then systematic non-probability sampling. So already it is non-probability. What is systematic? Even in the non-probability, I am selecting every kth unit as my sample. Every k or nth unit as my sample. That is systematic non-probability sampling. Then snowball sampling. Normally this is good for sociometric research and medical research. Medical research. For example, the medical representative, you know what they will do? They will go to the particular doctor. Sir, you can please write our medicines. Kindly tell me your friend who is comfortable with you and who will be listening to you. Will be listening to you. So he will be suggesting another doctor. I will be going to that doctor and collect the data. And she will be suggesting somebody else. She will be suggesting somebody else. This is called as sociometric technique by Murray. Sociometric technique by Murray. So this sampling is called as snowball sampling. Again, it is based on my convenience, comfort, discomfort, everything. I am taking the sample. Then next one is saturation sampling. Saturation sampling. Saturation sampling is like your sequential sampling. Unless you feel that you have selected every nth unit as your sample, the dense sampling. Unless you are selecting the nth unit as the sample, okay, you will not be satisfied. That is called as saturation sampling. That is known as saturation sampling. Then the last one is dense sampling. Dense sampling. Normally, you will take minimum 50% of the population as your sample. There is no randomness, nothing. This is my population. I have taken 50% as my sample. This is known as dense sampling. Dense sampling. 50% of the population. Right. What will be the effective sample size? Okay, there are certain formula. You can use the formula. But simple thumb rule is, if it is a survey research, minimum 10% of the population has to be selected as sample. Minimum 10% of the population has to be selected as sample. That is the effective sample size. Then, if it is the experimental research, experimental study, then minimum 30, n is equals to 30 and above is said to be the adequate sample. Adequate sample. So with this I finish the topic on sampling. In the afternoon session, I will be touching upon the tools of research. Yeah, you can ask any question.
Why do we use this dense sampling?
So dense sampling, see, we want to, the population size is small, we want to make the quick raw decision. We'll go for dense sampling.
Especially in ethnographic studies.
Yeah, all the ethnographic studies. We can go for dense sampling.
50% samples you will collect.
Yeah.
50% of the population.
Population.
Why is it
The
popular?
population size is very small. See, for example, forget about the Sanskrit University. People those who have the Sanskrit knowledge in Hyderabad city, which is, it will be a very small group only. All the people will not have the knowledge about Sanskrit. But in Tirupati, if you take the word Sanskrit, there are many people. So the group will be very smaller. So I took 50% approximately. There is no condition, nothing. I have taken. Yes, sir. Yeah, probability sampling, because which is the only available sample. I am not. See, how can you decide about the clinical people having the cancer? How can you decide?
But I think that incidental sample is a non-probability.
No, you think, but as per the methodology, they have placed it under the.
I am talking as per methodology.
No. Incidental sampling cannot be coming under the non-probability sampling. Accidental sampling is the non-probability. That's a minute difference between incidental versus accidental.
Accidental and judgmental, all are non-probability.
Yeah, they are non-probability sampling, but incidental,
Incidental also.
it is placed under probability sampling, and they have given the justification because you cannot decide about the viewer. You cannot decide about the people that are the clinical problem.
Incident also sometimes called accident. Incident means
Incident.
that is
We can argue like that, professor. But the thing is, try to understand my example. You cannot decide about the people those are having the cancer. You cannot decide about the people those have the AIDS. You cannot decide about the people those have the COVID-19. These are the incidents, occurrence. And not all the people are coming for the treatment. Even if you take cancer, many people they will identify the cancer only at the fourth stage. That is why their life cannot be saved. The life cannot be saved. That is why they are keeping it under the incidental sampling. In some of the recent textbooks, they have placed it under the. I have studied those textbooks also, but from the traditional textbook only I can give the information. In the traditional textbook, still it is under the probability sampling. I cannot give the false information. Some of the people they write the research methodology like even Kothari is a better book in my opinion. After Kothari, whoever is written the book, they have taken many of the information from the foreign material, web resources material, and they have written the notes as the book.
Yes, that's
Okay. There, according to their convenience, for example, even if you write the book, you can have your own argument and you can present something.
also I also read that is incidental is a non-probability.
Yeah, okay. It's up to you, but in the traditional book, it is under the probability sampling. Okay, fine. So, what is there? Follow some of the sampling.
JP Hughes.
That is a beautiful book. Pergamon Press. Hughes book is our Bible for our MPhil at that time. 95 the book was published. John P. Hughes book. And JP Hughes, John P. Hughes. The book's cost is at that time itself 95, it is 9,000 something rupees.
Not during 80s it was 70.
No, it was
70 pounds.
No,
70
it was
pounds.
revised and the final version was published in 1995.
I saw the
1995, we have forced to purchase that book. That is why I am removing the book. Big book. Yeah, but it is a beautiful book.
Yes.
But one should have the statistical stiffness, only then you can go through the book, which will be dealing with most of the equations.
As far as research methodology is concerned, nicely given.
Yeah, it's a beautiful book. Yes, sir, please.
Why do we need double sampling? Give an example.
Double sampling.
Yes, sir.
Double sampling is nothing but refinement.
Sir, we can get the first right, but why do we need?
Not two times, sir. You understood the meaning wrongly. First, I have selected. See,
Give an example, sir.
wait. See, from the Tirupati area, I have selected 1,000 people as my sample. Again, using any one of the procedure, I am limiting this to 500. This is called as double sampling. There are certain situations. See, in the first level of sampling, you would have used the simple lottery method. Now you want to incorporate the stratification. There are certain occasions we will do. So now I want to incorporate the stratification, like gender separation, more or less equal number of male, more or less equal number of female I want. So I am going for the second time sampling within that 1,000 sample. Within that 1,000 sample. So I am limiting myself to 500 sample. This process is called as you have followed the sampling procedure once. Again for the second time you are following the sampling procedure, hence it is called as double sampling. That's the reason. It is called as sampling within sample, not from the population. Not that you got the idea.
No.
Sir, first using the lottery method you have selected 1,000 people. Right? The weakness of the lottery method is we may not get the equal representation from men and women. Men and women and all the other strata. Now, from that 1,000 people, I am selecting 500 people using the stratification. Using the stratified random sampling method. This sampling procedure is called as double sampling.
within 1000.
See, normally this will not occur with the education researchers, but with the policy research, document research, and all these kind of problems may occur. We have taken the data from the government sources. After taking data from the government sources, only we will come across so many problems. Then from the first hand sample, we will be going for further sampling. This is called as double sampling.
Within the sample only.
Yeah, sample within the sample.
Population.
Sampling within the sample. Then.
Normally we don't follow, rarely.
Normally with the government data it will happen.
Hmm.
It happens with the government data or school education data. This happens. But when we go for the small level of research, this will not occur. But in your case, you can go for the double sampling as the example you have stated. In your case, especially yesterday you mentioned about the example, there you can go for double sampling. Or first you can go for cluster and multi-stage sampling. From there, again you can go for stratification. That will be giving the final data in your case. Then, yeah, let me stop here. Thank you.